Greetings. In this video I'm going to do a double integral of the introductory level, and the integral will be I equals integral sign limits a and 0 dx, and another integral sign limits square root a squared minus x squared and 0 dy. And working that out, the first part will be when integrating dy, it just becomes y, so that's the integral of between limits a and 0, y, evaluated between the limits square root a squared minus x squared and 0, and that integral will be carried out with respect to x. And then that equals to integral between the limits a and 0, square root a squared minus x squared, and then that's a fairly standard integral, but we can do it by letting x equal a sine theta, which means dx equals a cos theta d theta, and a squared minus x squared would be a squared minus a squared sine squared theta, which is a squared bracket 1 minus sine squared theta, which is a squared cos squared theta. And to deal with the limits, when x equals a, sine theta will be equal to 1, which means theta equals pi upon 2, taking the principal value. And when x equals 0, sine theta is 0, which means theta is equal to 0, again by taking the principal value. So our integral transforms to the integral between pi upon 2 and 0, square root a squared cos squared theta times a cos theta d theta, which simplifies to integral between 0 and pi upon 2, a squared cos squared theta d theta, taking the a squared outside, and the cos squared theta is equal to 1 plus cos 2 theta over 2. That's a standard trigonometrical identity. So that becomes a squared upon 2, integral between 0 pi upon 2, 1 plus cos 2 theta d theta, and then that's a fairly easy integral to perform. So that's a squared upon 2 bracket theta plus sine 2 theta upon 2, evaluated between the limits 0 and pi upon 2. When we put in the 0, everything disappears, and when we put in the pi upon 2, that becomes just pi over 2 inside the bracket. So the whole integral is a squared over 2 times pi upon 2, which is pi a squared upon 4. I hope you followed all of that, and thanks for listening. In future, I will try some harder double integrals, but this was just, as I say, an introductory level one. Well, thanks again for listening.